Alright, hello 8th grade. So today we're looking at analyzing data distributions, which is a lot of big words, but most of this is terms. And the nice thing is most of these terms are fairly intuitive. Most of them are exactly what they sound like. For example, if I've got a graph like this big group of stuff here is called a cluster. So if you got a group of stuff that's grouped together, that's called a cluster. If you have a big space where there's not any stuff, it's called a gap. The peak of your graph. So wherever your highest point is, that's your peak. So high point is your peak. And if you have a point, sometimes you will, sometimes you won't. If you have a point that's out here in the middle of nowhere, that's an outlier. Now, not every graph is going to have all of these. You might not have a peak. You might have a graph that's kind of flat. You might not have a gap. Maybe all of your stuff is close together and you don't have this. So you might not have all of these things, but you're going to at least have some of them. And you might have one cluster, you might have two, you might have a couple outliers, one on each side. So you might not have all of these things, you might have more than one of some of them. And the other two terms going on is if your graph looks exactly the same on both sides. So if there's a point where we could cut it straight through and it looks exactly the same, it's symmetric. Symmetry, that's a term you've heard before. So if it looks the same on both sides, it's symmetric. If it doesn't, even if it's close, if it's even just a little bit off, it's non-symmetric. So even if I added like another point here and another point here, that's pretty close to this, but still not quite. So in order to be symmetric, it needs to be exactly the same on both sides. So there needs to be some sort of line in the middle where you could say, yep, that's the middle, those are the same, those are the same. Now, that doesn't technically have to be in the middle of your graph. You could also get the same thing, like over here, if we had something like this. And it's not exactly in the center of where your graph is, but this would still be symmetric because there's a line here, even if it's not what you would normally think of as the middle of your graph. Because it's just the middle of where your points are. So that would be symmetric, but as soon as I do something like this, we're back to not symmetric. Alright. So that's the first thing we're doing with this. So then what we're going to do with this is we're just going to have a graph of some sort and we're going to analyze it. I should probably throw some numbers down here. So let's count by 4s. 4, 8, 12, 16. And then we're just going to figure out what's going on with this graph. So we're going to describe basically all of our stuff. And this time all of our stuff is really in one area. So this is our cluster. We have a peak at 20. So we do a peak at 20. We don't really have any big spaces. We don't have anything out here in the middle of nowhere. So no gaps. And no outliers this time. So sometimes you'll have this stuff, sometimes you won't, so don't freak out if you don't. It's sometimes there, it's sometimes not. You're pretty much always going to have at least one cluster. And that cluster is usually going to have a peak, unless it's exactly flat all the way across. Right. The other thing we're doing with it, oh, wait, hang on, that's not symmetric. So the other thing you want to say is it's not symmetric. Or no symmetry, or however you want to word that. So that's not symmetric. We have a cluster, we have a peak, no gaps, no outliers. Okay, now the other thing we're doing with this is if you see the word center and spread, think median and think interquartile range. Now, the median is exactly what it was in the last section, is you put all your numbers in order and find the exact middle. Your interquartile range, we found our quartiles before, so your interquartile range is what you get when you take your third quartile minus your first quartile. So regular range is you take your biggest number minus your smallest number. Interquartile range is when you take your third quartile minus your first quartile. Now, if we just have a graph, it's probably going to be easier if we actually have numbers. Because right now, just looking at this, well, it looks like, well, that's the middle of my graph, right? Probably not, because there's more stuff over here. So we're going to take a look at what those numbers actually are. So each time you have an x here, that's a repeat of that number. So this is a 1, that's a 2, and a 2, and a 2, a 3, and a 3, and a 3, and a 3. So if you actually go out and write out all those numbers, that looks like this. And really the big thing is just realizing that that's a thing you need to do rather than just looking at your graph and eyeballing, well, that looks like it's the center. Okay, so now we can actually go and find our median. So our median is the one in the exact middle, so I'm just going to cross off not these, not those, not those, not those, not those, not those, not those, not those. Oh, hey look, it's 4. So our median is 4. And now if we want our interquartile range, we're going to need to find our first and our third quartile. So if we found our median is 4, we want the middle of that splits that up into. So we want the middle of this stuff that comes before the 4. And we want the middle of this stuff that comes after the 4. And I'm just going to take this other 4 and I'm going to scoot it down here. So now if we're looking at this in the exact middle of okay. In the exact middle of that, we have 8 things here. So technically, the middle is going to be right here between that 2 and that 3. So we're going to call that 2.5. And the same thing is going to happen up here. The middle is actually going to end up being right between that 9 and that 10. So we're going to call that 9.5. So your median's where you split it in half. Middle of that are your first and your third quartile. So your interquartile range is going to be your third quartile, which is 9.5, minus your first quartile, which was 2.5, which gives you 7. Now, just a heads up that if you take that 4 and you said, well, no, that 4 is part of this, and you call this 9 things rather than 8, you'd get this as your center. And if you said there was another 4 here, then you'd actually get this 9 as your center. So just a heads up that depending on how you're treating that 4 that's in the exact middle, you could end up with something slightly different. The more points you have in there, the less that's going to matter. Alright, so we got our median, we got our interquartile range. Alright, now, next question is, what do we do with that if we don't have a graph? What if we have a box plot? And the answer is, it's actually even easier. Because if you have a box plot, remember when we were drawing these, that line that's going through the middle of your box plot, that is your median. So you don't even have to go through and find it, it's already there. So our median is that 15. That's already there. So the line going through the middle of your box there, that's your median. And then your interquartile range. Well, if we have a box plot, we already have our first quartile. So that's your first quartile, median, and your third quartile. And remember, this is your minimum. This is your maximum. Yeah, actually, technically, that's your maximum. This is an outlier. So if we have our median and our interquartile range, okay, well, our interquartile range is just our 30, which is our third quartile, minus our 10, which is our first quartile, which gives you 20. So we got our median, we got our interquartile range, and then if we want to describe what else is going on with this graph, okay, well, first of all, it doesn't look very symmetrical. It's not symmetric. And we've got an outlier hanging out over here. That's a 50. Now, the reason you're not going to really have any peaks when you have one of these is we don't know exactly where most of these points are. We can figure out, okay, well, we got a point at our minimum, a point at our maximum, but we don't even really know whether these are points because this could be a point or this could be the average between 2 points, so we don't know exactly where these points are. So we're not going to have a peak when we're talking about a box plot because we don't know exact numbers. We just know, okay, we've got some stuff here, some stuff here. These are really the only numbers we actually know for sure. Well, and our little outlier over here. All right, so you're not going to be looking for a peak when you have a box plot. And that is pretty much what's going on with that. It's a lot of terms, a lot of describing what's going on. So that is what's going on with analyzing data distributions. Go ahead and check out the homework, and I'll see you in the next section.